Hello students, I am Isha Medirata. In today's video, I will be discussing a type of semiconductor device that is known as a light dependent resistor. Now what do you mean by a light dependent resistor? It is also known as a photoresistor which will sense light and give output in the form of current. So though the name is a resistor, this is basically a semiconducting device which is made up of a specific type of semiconductor which has a high resistance. On absorption of light, the resistance will decrease exponentially and there will be an increase in conductivity. So let's start with LDR and discuss the working principle of an LDR. The working principle of an LDR is known as photoconductivity. From the name itself, you can say photoconductivity. Just split it into two parts. So photo means photons or light. So on absorbing light, conductivity of the material increases. Or LDR is a device which will have a very high value of current on absorbing light. Let's understand what photoconductivity is. So this is known as increase in electrical conductivity of certain materials when they are exposed to light of sufficient energy. Now why specifically light of sufficient energy? Now we all know that semiconductors are devices which have a specific band gap. Suppose I give you an example that I have a semiconductor having a band gap of 1.2 electron volt. So I would require at least 1.2 electron volt energy to send an electron from valence to conduction band. So if I want to send one electron from valence to conduction band, at least 1.2 electron volt energy is required. So depending upon the different types of materials, light of different energies should be incident on the material. Let's understand with the help of a diagram. So in the diagram, it's shown that there is a valence band and a conduction band having a certain band gap in between. So when light is incident, H nu is incident, electron moves from valence to conduction. So there is an electron in conduction and a hole created in valence. Thus, we say that conduction of the material increases because now more and more free electrons are available as they have moved to conduction band. Now let's see what exactly is the use or benefit of photoconductivity. So this photoconductivity, this process serves as a tool to detect the presence of light and measure the intensity of light sensitive devices. It is known very commonly used as a photosensor or a photodetector. Now let's see what is an LDR or a light dependent resistor. It is also known as a photoresistor because the resistance is going to decrease by absorbing light, and so it has a name photoresistor also. So a photoresistor is known as a passive component or a passive device whose resistance decreases with respect to the receiving luminosity on the component's sensitive surface. So when the component's sensitive surface or the active area receives light, suddenly the electrons will be released and they will move to conduction, and we say that conductivity increases. Let's see how an LDR looks like. So this is how an LDR looks like. An LDR, you can see a zigzag pattern in between. The zigzag pattern indicates the semiconducting material. The circular patch indicates the semi-insulating substrate which will hold the semiconductor, and then there are two metal contacts shown. So through these two metal contacts, the two leads of LDR are connected. Now how does an LDR look like? So you can see the orange colored zigzag pattern indicates the active region or the semiconducting material and the two leads of LDR. The second diagram also shows the two symbols which are used to denote an LDR. It can either be a rectangular box or it can be a resistor inside a circle with two indicating arrows inward, which indicate that light is being absorbed by this device. So this is how an LDR is seen or denoted. Now let's discuss some of the materials which are used in the construction of LDR. So as I mentioned that LDRs are basically made from semiconductors which have high resistance. Now what is the use of, why do we use such materials which have high resistance? Because in normal circumstances, if the semiconductor is having high resistance, it won't give you any current as output. But when this device is exposed to light or when it absorbs light, suddenly the electrons will move to conduction band and suddenly the conductivity of these materials increases. Clear? This is how LDR is denoted. It has different packagings. The silver colored cylindrical structure surrounding it represents the, you can just say the protective layer, and in between the zigzag pattern indicates the semiconducting material. Let's have a look at some of the materials which are used in the construction of LDR. The first one of them is cadmium sulfide, then we have thallium sulfide, cadmium selenide, and lead sulfide. So these are some materials which are commonly used in the construction of light dependent resistor. Now let's discuss how LDRs are constructed. So if you talk about LDR, you can just see the diagram. The diagram has a semi-insulating substrate. Above that, you have an active region, that is the semiconducting material. Then you have two metal contacts. So what is the use of this semi-insulating substrate? The use of this semi-insulating substrate is to hold the semiconductor, and on the semiconductor it also has two metal contacts. You can just see from the diagram that the entire light is made to focus on the active region only. That means the moment the light is absorbed by the semiconductor, a huge number of free electrons would be released. Clear? This is one more diagram which shows how LDRs are constructed. So there's a circle, in between them you can see the zigzag pattern of the semiconductor. You can see two terminals which are connected to metal contacts, and the light green colored portion indicates the semi-insulating substrate. LDR is constructed by placing the material in zigzag shaped strip of photosensitive device upon an insulating material. So what is done? There is a material, a semi-insulating material. Above that, in the form of a zigzag pattern, semiconducting material is placed, and then you have two metal contacts, and this is the very easy and simple construction of an LDR. Light sensitive materials which are used over here, which are also known as the photosensitive materials. The examples are cadmium sulfide, thallium sulfide, then you have cadmium selenide, you have lead sulfide, some common examples. The insulating material which is generally used is ceramic. Then you have metal films which are connected as metal contacts which form the two terminals. And all this, the entire structure, means substrate, semiconducting material, and the two metal contacts through which two films come out as two terminals. This entire is placed in plastic or resin case so that a proper or bright exposure to light is done. And it also prevents it from dust and dirt. Clear about the construction of LDR? Now let's move ahead and discuss the working of LDR. Now in this diagram, I have shown two different meters. The first portion shows that the LDR, which is at the bottom portion, it is connected or it is exposed to daylight, bright light. What happens in this case? If this LDR is exposed to bright light, just look at the value of resistance. It is hardly in ohms. Why? Because when light falls on the LDR, what happens? The electrons from the valence band will move to conduction. Why? Because the covalent bonds break. So huge number of electrons are released and they move to conduction band, thereby increasing the conductivity of the semiconducting device and decreasing its resistance. Clear? Just have a look at the other portion of the diagram, which shows that there is no light. Night or dark is shown. In this case, what happens? The electrons from valence are not able to move towards the conduction band. So what will happen? The resistance of the device is very, very high. You can see from the diagram it is in range of kilo ohms. So I can say that it has a very high resistance in dark and the resistance decreases when it is exposed to light. So this is how an LDR works. Photoconductive material, as I said, it doesn't contain free electrons, or it has a very few number of free electrons, so the amount of current is negligible in the absence of light. I'm talking about when it is not exposed to light. But when light is incident on this LDR, as I said, covalent bonds will break and electrons and holes are formed. These electrons will move to the conduction band because they have gained energy, so they jump to a higher energy level, thereby giving current. The resistivity of LDR decreases with the decrease in incident light, and vice versa. You can see that if more and more light is incident on the LDR, if a bright light is incident on the LDR, what will happen to its resistance? Its resistance will decrease and conduction will increase. So now just understand with the help of a small animation over here, which shows you different intensities of light, and according to that, see how the current varies. So starting from dark, then bright, and then bright, you can see that the current is also increasing according to the brightness of light or the intensity of light. Now, let's discuss the characteristics of an LDR. So characteristics here, I mean to say how resistance changes according to the light intensity, or what is the variation of resistance with light. So starting from dark region, average and bright sunlight, just have a look that when the light is not present or when it's completely dark, the value of resistance is very high. But as you see, as you move on to average and then you move on to bright sunlight, you can see an exponential decrease in the resistance of LDR, which clearly means higher the intensity of light, or brighter is the light, lower is the resistance, and higher is its conductivity. So I can say that when there is no light, resistance is very high, and when the LDR is exposed to light, its resistance decreases and it is in order of ohms only. Clear about this? Now let's move on to advantages of LDR, starting with the first one, which shows that LDRs have a very low cost because less number of components are required in its construction. It has a low power operation, it has a higher sensitivity, it is available in many shapes and sizes as we saw the different packagings available. Now let's discuss the disadvantages. So as such, if you discuss about disadvantages, LDRs have a very large response time. Only that is one disadvantage of an LDR. Let's have a look at some of the applications of LDR. So it's used in automatic street lighting, it can be used in cameras, it can be used in alarm clocks, in burglar circuits, and it is also used to count objects in conveyor belts. How can this be used in conveyor belts? The moment LDR is exposed to one of the objects, for a moment there would be a change in resistance and that is counted. So it's used as a counter. Clear? So in today's video, we have seen what is an LDR, what is its working principle, how is it constructed, how does it work. We have also seen some of its advantages, disadvantages, and applications. Hope you have understood all the topics I discussed today very well. Thank you.